Yeah, we're live. Something was going on there. It's not letting me cooperate there very well. But we are live, and tonight we're going to talk about turbo stuff. We have turbos back in stock at richardoldnerperformance.com, and the GTX 3584 RS turbos are. You've seen some videos I have up. We've run them on 5.3s and stuff, and I don't think we ran one. I think we ran one on a 6 liter. We want to, and I'm also going to run twins on them. And the reason that I want to talk about that, we have the G42s too, which will go to 1200 horsepower. So we got two good turbos. And then I think on the GTX 3584 RS turbos, we have journal bearing and dual ball bearing setups. The dual ball bearings are obviously more money, but the journal bearings are less. And a lot of guys want the dual ball bearing stuff because it's a better turbo. It does cost more, but it is better. It's not going to do a bunch in terms of like response rate or that kind of thing, but for longevity and like I said before, I've talked about it that it seems to be that it will take momentary lapses of oil pressure, oil starvation, better than a journal bearing will. But once you have oil there, everything works great and all that's fine. So that's something to think about. And like I said, we have both of them. You do pay for that, though. Like I said, it's just more expensive. But the question is one now about, we know that when we run, like if I had a 4.8, I'd definitely put a single 3584 on it because it's going to be, the boost response is going to be great. You can make a lot of power. The thing's rated for 900. I don't know that you get there on a 4.8. I think you could get to 900 on a smaller motor that's going to have less back pressure, but we've already gone past 800, so we know that we're going to get close to that even on a 5.3. So on a 5.3, a 4.8 works great. I would even run one on a 6.0 as long as you were just trying to make, run 7 pounds or whatever, and you were doing it more for towing or for street response and that kind of thing. On a 6.0, it probably would opt for the G42 turbo, particularly if you're wanting to run 10 or 15 pounds and you're wanting to go in, which is going to take you, up into the 4-digit power level, and you want to do that. I would put that bigger turbo on there. But the question is, what about twins? What about twins on a 4.8 or a 5.3 or a 6.0, particularly on a 6.0? But twins on anything, let's say. So we're looking at twins on a 6-liter, two of these GTX 3584s. Because what you've done when you're putting twins on something is you're doing what we did on that asymmetrical turbo test, where we just ran the exhaust from one side of the motor to a single turbo. In this case, that GTX 3584 RS turbo, we ran the exhaust from one side of the motor to the turbo, but then the turbo turbocharged the whole motor. You just had a header on one side that was exiting out, and you had half of the exhaust energy feeding the turbo, and the result was a rising boost curve. And with that turbo and the FSP, the Fowler Performance FPS, at any rate, the log style manifold, it was better because it offered better boost response, and so that it ultimately made more power. But this isn't unlike having a twin setup where you have half of the exhaust energy feeding each of the turbos. Now that situation is going to be better than it was in our asymmetrical form, because if you are feeding the motor, even though you're feeding the motor with half of the exhaust energy like we were, you're getting more total energy going in, more total energy potential and more power output coming out of the motor, which translates into more exhaust. So if you have, for instance, if you spool up both of those turbos, let's say we were to spool up one turbo and it has a rising boost curve, and spool up the other turbo and it has a rising boost curve like we did under asymmetrical deal. Well, but now the boost provided, so let's say that at 3,000 RPM, we were making 2.5 or 3 pounds from one turbo, just half of the exhaust feeding that. Well, if we did that on this side and on this side, we now don't have 2.5 pounds coming from one turbo. We have 2.5 coming from both turbos, which means we are going to have a lot more boost. And then the resulting thing of having a lot more boost, a lot more airflow going in there, and a lot more boost going in there, is now we have more exhaust energy. And so what's going to happen is it's going to act like a turbo system does, not like our asymmetrical turbo did. It's going to act like a turbo system does. It's going to have better boost response. It's going to have more power. It's going to have unlimited power to wherever those particular turbo, whatever that particular turbo sizing will take us. And it will take us farther than half of what one of those turbos will do, because we've done two things. We've doubled the compressor size and potential flow rate of the turbo, but we've also reduced the hot side flow because we're only having half of it feed the exhaust side. So rather than all of the exhaust feeding one side of a single turbo, which is ultimately the limiting factor on that turbo size, on that displacement, if we're cutting that in half, it's a much better combination. And so the turbos are going to be much happier, assuming that we were wanting to like max the turbos out. So they will be much happier. My question is this, though. I mean, with these GTX 3584s, let's even artificially limit them. I don't think we would limit them at 800 horsepower each on a twin setup. I think we'll get closer to 900 horsepower. But would you run those turbos at like just 1,000 horsepower? So let's say we have 1,700 horsepower worth of turbos. Would you run that at, like, let's say you wanted to make 1,000 at the flywheel or 1,000 at the wheel? Would you run those turbos at that level, or would you only look at, hey, I'm trying to get to 1,500, and those turbos will definitely take me there, and they'll have good response? So are you the 1,500 guy, or are you the 1,000 guy? So I'm not probably going to do 15 at the tire, 15 or 16 at the flywheel. It might get there. I don't know. But it'd be close depending on the drivetrain loss. But are you going to do that? Would you run? Let's see if that will be our poll here. Okay, would you run 1,500 to 1,600 wheel horsepower worth of twin turbos on a 1,000 wheel horsepower motor? What we're trying to find out here is basically how much would you leave in reserve? So if you were trying to get, and we get this kind of question a lot on turbo stuff. And this is a question for any turbo application, single, twin, whatever. How much are you leaving on the table? So let's say you want to run, 600-700 horsepower. Are you getting a 700 horsepower turbo to do that? Or are you getting 1,000 horsepower turbo to do that? Or are you getting a 1,200? So let's say you wanted to run 700. You got a 5.3, you want to run 700 horsepower. Are you getting the GTX 3584, which will do, is already done 800 on a 5.3. Let's talk about flywheel numbers. So would you get that? Would you want the response rate of that? And knowing that you have, if you want, let's say 700 was your target number, that's your bogey. We know that this turbo on a 5.3 will go to 800. In fact, I'm sure that it will go beyond that, at least another 50 or 60 or 70 or something like that. It's going to go beyond that. So are you leaving that kind of room and then you want the response rate? Or are you going to the G42 that can do 1,200, but do 700 really efficiently? Are you doing something in between there? I want you guys to let me know in the comments, because this is kind of a good discussion. I'd like to know where people are. There are ideal situations, and then there are like real situations, and then there are other things that we would consider when we're thinking about these kinds of selections. Cost is a really big thing, a really big driver for people getting turbos. Sometimes people use turbos that they just have laying around. I mean, I've done that a bunch of times when we run stuff, that's why that GT45 deal that I ran so many times, that's why I got used so often. Not because it's the best turbo, it's not. It's not. We've shown that it's certainly not. The GTX 3584 turbo that we have at the store is a better turbo in every respect. It's lights off faster, it can make more power, and so on both ends of the spectrum, it's better. But it's not what I had. I have them now, but I didn't have them at the time when we were doing all this testing. So we ran that turbo, the GT45, on like everything. That's because it was a turbo, just in the same way that Matt and all the sloppy guys are running the sloppy stage 2 cam. It was a cam. It worked. You know, it is an LS cam. We'll go in there, and as we know, every cam. And so it was there and it worked, and that's why we use this turbo. It's not good, it's not the best one, not one. It's one that I knew that if we put on there, it was going to work. And so when people ask me, well, if you wanted to do something and put a turbo on there, here's what this one did, and if you want to get this one, it was cheap, and you know it would do. It had turbo-y goodness. Was it the best one? No, not by a long shot. But and so a lot, I'm guilty as everybody is of using the thing that we have. Same thing with cams, same thing with heads. So, you know, if I have an engine that's already assembled and it makes it easier for me to complete my tests and get more testing done and use more valuable dyno time, there's no reason that that's not going to happen. And that's a good, you know, it's good reasoning for the average guy to you. Hey, somebody gave me this turbo. It's a GT45 or it's a 7875 or 7875 Gen 2 or whatever it is. I have this turbo. Will it work? Almost, the answer is almost always yes. If it's a 38 or 46 millimeter turbo and you're trying to run it on an LS, yeah, it'll work, but it's not really going to make very much power. It might not make as much as your NA motor makes, and so it's probably not going to be a good choice just because it is a turbo. Now, if you had two of those, we could talk about something there. But as a single, you know, there are things that won't work just because it's a turbo. And I've had to go over that with a number of people. Hey, I got this turbo. Well, every turbo is not the same. Every cylinder head is not the same. Every intake manifold is not the same. Every camshaft is not the same. Just because it is a camshaft, and it is going to make the lifters or make the valves open and close, that doesn't mean that it's going to make a lot of power. The same thing with turbos. You might get a turbo from a wrecking yard, and while it might work on the Cummins or the Power Stroke or whatever that you pulled it off of, that doesn't mean just because it's a turbo that it's going to work on, you know, your motor where you're trying to get 700 or 800 horsepower. It might not do it. And now twins, again, might get you there, but one of them is not going to work. So there are better applications. And so the question here is, you know, how far would you go? Do you want to keep it? Do you want to, in an ideal situation, if you don't have it and you're not getting it for free or whatever, or the cost is in line with other things that you could choose, do you want to choose something that, you know, has the best response, the combination of response rate and has you covered by 100 horsepower or more in that range that you're kind of wanting to run? Because what we always talk about is when you have a turbo and you run 7 pounds, it's going to be 8 and 10 and then whatever. And then pretty soon, if you have given your, like, you can't go, okay, look, I want to make 500 horsepower, but I'm going to put a 1500 horsepower turbo on there. I don't think that that's a good idea. But if I'm gonna try to make 500 horsepower, I don't think it's a good idea to put a 500 or a 600 horsepower turbo on there, because that doesn't give you room to grow. So the question is, out of this extreme where it's 1500, maybe that's not a good idea. 500 is not a good idea, or 600 is not a good idea. Somewhere in between there is the good idea. And my question, obviously, for tonight is, where do you place that good idea? Where, and this is subjective too, where I would want to do it, and for my application would be somewhere, and where other people would want theirs, just like with camshafts, that they want this amount of idle quality and this amount of chop and this amount of converter usage and all that stuff. And so when you're selecting turbos, we get the same thing. What a lot of guys want, and this is what they say, same thing with a camshaft. Can I have like a perfect idle quality, or the idle quality, whatever that is that I want, and have all the low speed power, and then have all the mid range, and then have all the top end too? No, you can't have that. And with a turbo, you can't have all of the boost response and have immediate boost response and have it come up, you know, at 1,000 RPM, and then also have all of the top end charge and make the 4-digit plus power level stuff. That's just not, that's not in the cards. And so you have choices. You have choices in that middle efficiency range that we're talking about. And that's why I asked this question about where are you on that efficiency range? Would you run a 15 to 1600 wheel horsepower worth of twin turbos on a 1,000 wheel horsepower motor? 53-47. So we're kind of split there. Knowledge Lunchbox, what's going on? No name. Oh, Mr. No Name Nobody. There you go. Twin turbo 496 Vega. Rain Man. Not Rain Man. 1 or 2 turbos, whatever it takes. That's right. S475, S476, whatever it takes. Hit the like button. Do you have a recommended shop to do intake port matching? I don't know where you are or who does stuff like that. Have you tested the 3584s in twin configuration? I have not yet. We do plan to. We haven't tested lots of twin turbo stuff. We do know what they'll do. Twins on a 6-liter diesel. You have that on a diesel already? That is the truth. What's the price difference? I need to send you and my turbo back. Well, you need to send your turbo back for what? I want to use 6260s, excuse me, 66s on my 5.3, 0.96. You want to use 2 of those? And again, the number one thing, and when you're asking a question, is you got to tell me what your desired power output is. Did you ever get 3X shirts? We don't have, I don't think we have any 3X shirts left. Richard, do you put a torque wrench on LS rockers? I do not. Haven't ever put a torque wrench on factory rocker bolts. Where can I get the turbos at? You can go to richardholdenerperformance.com. No need, just torque them until the elbow until the elbow clicks, till they strip, and then back it off half a turn. You don't want to do that. But having done, I'm going to say hundreds, but because it's 16 at a time, I'm sure it's thousands on the dyno, and tightened and untightened from all of the camshaft changes that we've done and cylinder head changes and all the various changes that we've done. I've taken apart and put them back together a lot of times, and I don't ever torque them. What I do is I do like to make sure anymore, because I don't want there to be a major catastrophe while we're in the middle of checking. Because before, especially when I was younger, I was in too much of a hurry to get everything down. Let's just run all those down. But anymore now, I like to take the plugs out. I like to tighten the ones. I run them all down with a gun until I start feeling resistance. I'm not impacting them. I'm just spinning the thing where it'll free spin. And then I go and hand tighten all the ones that are on the heel of the cam. Then I rotate the motor to get sometimes there's none on one side and some on the other, depending on what position the motor's in. But I do all of the ones that's on the heel of the cam. I rotate the motor, and then the other ones will drop, and then I'll do those. I try not to tighten or loosen any of the rockers when they have spring load on them. And so I'll go through that procedure, particularly if we're doing lots of swaps on stuff. So if you keep zinging those in and out and with spring pressure and stuff, it's easy to pull the threads out and stuff, because you don't know how many times that's happened on these junkyard motors and stuff, and you just don't want to do that. I've seen guys just really get after it with, oh yeah, I got these impacts, I'm going to do this. I'm like, yeah, that's not for me. Even when I do head bolts, I undo the head bolt by hand, and then I zing them out with it. I just use the gun to do the quick stuff. I'd like to run twins. It looks sexy, but my issue is having the room. It is that you have to decide whether or not. I mean, the symmetrical thing is kind of cool, and a couple of guys have talked Jimmy into getting the mirror image turbos, which we have to order. So that's going to be a while for those people that want to wait. but it doesn't work if you don't have the room to put both of those turbos there. Getaway, what's going on? 1200 horsepower guy here or somewhere in the middle? Okay. You said no XD. I'd really be happy with 425 wheel horsepower. That's pretty easy. Only if it doesn't hurt the responsiveness. Yeah, it does. And that's the other choice is, let's say that you wanted to be, you want to make 1,000 horsepower. A guy that's going to make 1,000 horsepower is always going to go up. But if you want to make 1,000 horsepower, the very best response you could get would be those turbos that just barely eclipse 1,000 horsepower. Then you get all the response on this side, and then you get the 1,000 horsepower. The way that guys do better and make more power is they get a turbo that's capable, or turbos that are capable of more than that, and then they bring this response side up, like when they're drag racing, with a variety of methods. You could use a two-step, you could use a quick spool valve, you could use a converter, you could use a lot of different things to get the thing in the RPM range where, hey, look, we have boost now. And then now it's just, it's ready to go. Drivability and cost, mostly for me. I believe it's less stress on the parts. Twin GT3582s on the 4th Gen 4.8. Again, AE, you got to tell me for what power level you're trying to do with that. Been tearing around on my new Coleman pit dirt bike. Nice. Covered in mud. That's good. Do you plan to sell the Buick 455? That motor's still apart, but I do have lots of good parts for that. I like to do 1,000, but conservatively use 650. That's the nice thing about a turbo setup is that even if you have 1,000 horsepower or 1,500 horsepower with the turbos, you don't have to use all that. You just use what you want to use. Is more overlap less desirable for turbos with the exhaust valve and intake being open simultaneously bleed off the boost? So here's something to think about, Dan. I get this question all the time because it's a very common one. It's a common misconception among overlap. So a couple things. First of all, with overlap, what people don't realize is the time element of overlap. That while a motor is running, and it changes obviously with engine speed, how much time the overlap is actually happening. And then also the overlap doesn't do what you think it does, because if you have 10 pounds of boost, especially at higher engine speeds, you have 10 pounds of boost, you more than likely have at least 10 pounds of back pressure. But honestly, it's more likely that you have 20 pounds of back pressure. So in which direction would that actually flow if you have more back pressure than boost pressure? A lot of people think, that's overlap. All the boost is just going to escape out the exhaust. Well, it can't, because it has stuff blocking it. And also that sort of scenario is not really taking place. And if it is taking place, it'd more than likely be more pronounced at one RPM more than another, probably lower RPM. But that's where the cam is also maybe making less power, but not always, because overlap isn't always your enemy. I have run lots of camshafts with overlap. The low buck truck camshaft that we sell is an example. It has overlap. And lots of cams, the Truck Norris cam, Chupacabra, lots of cams have overlap, and they work fantastic with turbos. And so those two things don't, there's a correlation there, but not a causation. Scrolling. Big downside of PSD turbos is reverse rotation. Hopefully getting a new shed to rebuild the Kawasaki. Nice. I want to choose something that will put my car 580 in the 8th. Well, how much power will that take? I don't know what the weight of your vehicle is and what the gearing and all that stuff is, but roughly how much power is that? C4 Corvette with LS twin turbo equals homemade sledgehammer. Yeah, you can easily do that. You can easily make way more power than they made with the sledgehammer car. that with that motor. I mean, 1,000 horsepower with a, like my junkyard L33, even with just that single G42 turbo on it, you know, has already made a lot more than has made more, I think, than the Sledgehammer did. And it was not, it was only at like 15 pounds, so it was ready to do. I mean, that turbo will go 1,200, and so if you wanted to do that, getting that sort of power level is pretty easy. Keep the hot side pressure down and not have insane EGTs with maxing out a turbo. I like turbos running at 80% versus maxing out. I like my turbos to run like injector duty cycle. But I've definitely done the other thing. I disagree. At the 1,500 horsepower level, you can have a perfect idle and good drivability and perfect response and a great top end. But you have to buy a Bugatti. That's pretty expensive. At the point I'm going for 1,000 horsepower, streetability is getting real low on the list. 1,000 horsepower with a turbo application, streetability should not be low on the list. It should be, you should be able to have that. And the bigger that you go on the motor, the more streetable that could be. Like a 6-liter and a fairly mild cam and boost is easy. 1,000 horsepower is easy. Set it at 1,000 horsepower boost level and have 1,500 horsepower on tap with the Scrabble button. That's right, Scrabble. C6 with an LS3, considering a cam upgrade while I replace the balancer. Any recommendations for a smaller cam for daily driver? Yeah, the one of our cams, the Lobo truck camshaft, would be good for that. Have you done much with the stock 6.2? Yeah, I've run lots of stock 6.2s. Lots and lots of them. Lots of different versions of that. The LS3 and L92. The LY6 is a 6-liter. Twin GT3582s on a 5.3 work very well down low and have a decent amount of headroom to push them hard. Assuming every supporting mod is done appropriately, what do you think the horsepower limit on 91 octane is for a turbo 5.3? I don't know. The supporting mods don't matter. What you're looking at is the detonation threshold based on boost and timing and octane and intake air temperature and water temperature, all the things that are going to determine where you can, how far you can push this. And I don't know what that is. Bonneville 650, 700 at the wheels, 4.8, 6,500 RPM. Would you recommend 3584? I would recommend a G42 because for Bonneville, you don't care at all about response rate. And a G42 will make more power than the 3584 will. And for 700 at the wheels, that's near the limit of the 3584. Question about motor configurations that are available for a 6-liter. Yeah, you're here. You're at the right spot. Ask away, man. Think setting up a V8 fogger as a 2-stage kit running half the cylinders on different amounts of nitrous at different times work well as a low buck traction control. Are you only injecting some of the cylinders with less amounts of nitrous? I think doing that way is not as good as doing a stage setup and then also a progressive setup. I'm stuck in Chicago, working 14-hour days driving, but working on the project. Still need to buy a wastegate and blow-off valve. Would a 50 millimeter be good for a 7875? I think I might go bigger than that. I'd need to see how good the flow rate is on a 50. I don't remember testing a 50. We're going to be testing wastegates here pretty soon, and so I should have more information from you or for you. When running a 408, is there a similar option to that with a stock cam? Do you mean you want a camshaft that will do in the 408 what a stock cam does in a 6-liter? Is that what you're asking? Eric, you're working with a GM 3800? Oh, okay. I don't even remember what power number we were talking about. Definitely break bolts loose by hand to see what they're at, if they're important. Yeah, I just like better than zinging them off. I just think it treats them better if you unbolt them. Most of the time on the LS stuff, it doesn't matter whether it's a Gen 3 or Gen 4, we normally don't reuse those. We have cans of both of those sitting around just in case I need some for the dyno, and we have to run, like if I'm running an NA thing, I don't care about reusing those bolts. We just put them on, I torque them to 65 foot-pounds, and we call it good, and then we start testing because it's not going to leak. I don't do that on boosted stuff, though. What AR to use for 6266 on a 5.3 drag and drive? I don't know. I don't know what's available on those. Oh, a 96 or an 81. I think you'd be fine with 81s on a 5.3. And I don't know also what the rest of the things that you have for a drag and drive. I don't know what your stall speed is. I don't know what your gear is. I don't know what your transmission is. I don't know any of that stuff. And I don't know how far you're going to push those turbos. If you're trying to max the turbos out, would go, and you have a higher stall speed or a two-step or something like that, then I would go with a 96. My next gen 7875, I'm pretty impressed with, although it's my first turbo, so I have nothing to go off of. But I'm saving up for G42 6-liter LS, probably 900 tops. But I want to get there fast. Yeah. I think that 900 is in the wheelhouse of that 7875. This configuration for a 6-liter with a stock crank, that's good for boost. Are you, CJ, you got to tell me how much power you're trying to make. How come you don't review tick camshafts? I don't think I've seen them on a comparison video. I have run tick camshafts. Not a bunch of them, but we have. The nice thing though is that, and in fact, I have one of their intercoolers that we've run that I really like. I think I did include their stuff in the shootout when we compared a bunch of stuff to the sloppy stage 2. And I've run a couple of their things in the past. But the thing is, if you look at a camshaft that has comparable specs, it's going to do comparable things. Does overlap really matter if you get the power you want? Well, that's the thing, and that's what a lot of people that do camshafts, they don't have dyno data, they don't have test data. They talk about things like that, and even more so, people that don't do camshafts talk about that. Oh, this has too much overlap. I'm like, but have you ever tried it? No, it just has too much overlap. Well, how do you know what that is? Like I said, the low buck truck camshaft has overlap. Now, that can't work with a turbo. No, it works excellent with a turbo. We know, we've already made 600, 700, 800, 900 horsepower with it. We already know, and it just keeps going up in relation to whatever the NA power output is. It does that because that's what turbo motors do, irrespective of overlap. Want to do a poor man stroker for my 31,000 mile original 99 two-door Cherokee? Okay. Wouldn't that size have too much back pressure at higher boost for, I don't remember what we were talking about. Chamber style, yeah. Basically, the detonation threshold is the kind of thing I was going at. Have you ever gotten power out of an inline 6-cylinder from a Jeep? I've never tested a Jeep engine. What do you think of an Ilmore LS3 intake? I bought on the marketplace. I sent you a Facebook. Does it look like a performer or a cool paperweight? No, I think it looks cool to me because I've never seen one. I mean, I certainly have never seen one in person. I don't even remember actually seeing a photo of one of those, but it would be really cool to try to test. Have you seen the compressed air supercharger stuff? Yeah, I was at West Tech years ago when they ran that. Inject half the engine from the hit and then the other half at a later time. Yeah, you could. I guess you could try that. I mean, I think I'd rather inject all of them with half the amount of nitrous. Extreme budget Gen 3 5.3 iron block boost build low buck truck camshaft. Yes, that's what I would pick. I would pick our cam and spring package. I don't think you could do better than that. And then you're going to need injectors. You're going to need some kind of turbo. We have all of that stuff there. On my plan to possibly install twin GT2871s that have internal wastegates, would I need a blow-off valve running a blow-through on a pressure box? A blow-off valve would be a good idea. And are you running it as a blow-through carbureted deal? Better to have a little bit too much turbo than not enough. What is making Chevy 6.2 motors blowing up in the new trucks? I don't know. Does anybody know what's going on with what the deal is? Those are LT motors and not LS motors, but I don't know what their limitation is. I don't know if it's an oiling thing or what it is. What twin turbo setup would you run on an LB343? How much could each make in horsepower? How much power do you want to make? You got to tell me that. And then how much power you want to make will dictate what size turbo we would put on there. What's the deal with 6.2 recall? I don't know. I'm not familiar with that. That's what I just said. I don't know what the problem is with the LT motors. Does anybody have any idea? What's the difference between a ball bearing and a journal bearing? I want to say it's like $150 or something. And I can get my turbo sent out to you by Friday. Can you sign my turbo with Super Richie? I don't have them here. Jimmy has them. And did you talk to Jimmy about swapping one of those? Todd, what's going on? Todd, did you try that tune that we did? Have you started that motor up? New motors are breaking the cranks because of the stretch belt setup. Have you seen a 2-barrel blow through or a Q-jet blow through? I haven't seen either one of those, but I'm not sure why you couldn't do that inside an enclosure. Certainly a 2-barrel Holly would do that. The Q-jet, I don't know. I would think that the air door would still work, but I'm not certain. Yo, everybody hit the like button. We got 52 likes and 112 people here. Come on, man. Sure, I got an M90 for $50. When you ran the LS was a 7.5 crank pulley and 2.6 supercharger pulley. I want to put it on my 318 with 360 heads and have cheap fun. Yes, you're going to need a big crank pulley. We had the truck damper on it, and then the 2.6 supercharger pulley to get it to work. We've also run a ported one, which helped. You want to put as big a throttle body as you can get, and anything that you can do to enlarge the inlet going into the supercharger, like make that hole bigger, will definitely help. People get caught up in small stuff. Yeah. Would you ever build an LS from Temu? Like, didn't somebody do that already? I tend to trust this guy about cams. Why the best if good enough gets you where you're going? I don't know that. I mean, and I can't speak for everybody here because I don't know what your financial background is, but getting the best of something is really expensive because what happens is you can get 90% of what you're trying to get for a pretty reasonable price. The next 10% is like exponentially more expensive. And so that's why I don't go after that stuff. Would you recommend a Truck Plus cam or the initial low buck truck cam for an LQ9 with a G42 seeking higher mid-range performance? Goal is 700 horsepower to the wheels. 700 horsepower to the wheels is still, I mean, you could do 1,500 horsepower with a low buck truck. So it has nothing to do with power output. It has everything to do with, do you want the turbo to be responsive? If you want the turbo to be responsive, and particularly on a G42 turbo, if you want to be responsive, you should put a low buck truck camshaft in it. Because the Truck Plus cam isn't going to make you more power. The turbo is going to do that. Especially if you only want 700 and you're putting a turbo on that's capable of 1,200. The turbo's like, hey, we're not even breathing hard here. I got your low buck truck cam to run 2 GT3582s. I got the 61 Air because it was the smallest. I know I won't use all the turbo before I break stuff. Engine, trans, drive shaft. Let's see. All of that will work fine. Just as long as the tune is right, it's going to work fine. The recall is due to manufacturing defects, crankshaft and rods damaged during manufacturing. Turbos, blow-off valves, not so good if you have to pedal it, but turbos might get pissed off without a blow-off valve. I'll send the Ilmor intake out to you if you want to do a test with it and send it back when you're done. I'm tempted to do that. I'll send me an email, okay? I put my email address down there. Richard, did you ever run an S475 on a 3800? No, I've only ran one turbo on there, and it wasn't that. It was probably the GT45 or the VS Racing turbo. Have you seen the price of an enclosure? I have. I might have an enclosure. I don't think I have an enclosure. I think I have the Jupiter 2 like space bonnet that goes on top of there. Yes, I have the data run safe. So Todd, you did get it running, and it's running and driving around? The story is bearing failure, but the 3 I've seen bought as cores had powder metal rod failures. After seeing those tore down, makes me leery of a powder metal rod in the US. In an LS, well, you shouldn't feel anything. You shouldn't feel leery at all about the connecting rods in an LS, because those have been out since 99. Is that when they came out? Why am I having a hard time? Yeah, 99, 2000. Yeah. And we've run endless stuff with them, and not just me, everybody in the industry has. And so it's not a rod problem. I don't know about the LT stuff. I don't know if they have the same rods, if all that's the same, but factory LS rods are not a problem. Trying to accomplish 900 plus with a stock 6-liter crank, is it possible? And if so, what configuration? Yes, it's very, very simple. The 5.3 that we have, you take a look at the last few stories that I did, the last few videos that I did. 5.3, stock crank, stock rods, stock pistons, ring gap, stock heads, our low buck truck camshaft, Trailblazer SS intake manifold, injectors, and one of our turbos, and it did 925 at 15 pounds. So that's not hard at all. The stock crank has gone to 1,500 horsepower. So the crank isn't an issue. You won't hurt the crank. It's been a while since I've been on the live. I've been looking into jet ignition. Have you heard of these before? I'm really interested in working on a system for either an LS or a K-series motor. I don't know what that is. And if it's what I think it is, ignition systems are not going to add power unless there is misfire. So for instance, we ran the stock ignition system on the factory coils, LS3 coils, on the 1,500 horsepower LS motor, stock coils, 4.5 milliseconds of dwell, 18 or 19 thousandths plug gap, just stock junkyard wires, and nothing special about the plugs. I think that they were Denzos. So if we don't get misfire with that stuff, I don't know what a better ignition system is going to do. I live a mile high. And all heavy stuff, early steep hill, swap to 410s. No converter yet, but planning on using a 331 gear and a 3-speed 400 trans. Watched a lot of video on cylinder heads. Why do you suggest using stock heads a lot? Because you don't need the power output that you're trying to get. You don't need to upgrade your heads. It's not necessary, because you can make, like I said, on the 5.3, we just, if you get a 5.3 that makes, like in our case, it made 430 or 440 horsepower. If you double that at 15 pounds, and then we ran E85, so we got a little bit better than that. But at 15 pounds or so, we're over 900 horsepower. And every motor does that. And it did it with the stock heads. So if you can do that with the stock heads, you don't need different cylinder heads. When you need different cylinder heads, is one, when you'd be looking for 1,500 or 2,000 horsepower, but more than that, when you need the extra thickness that the decks have on aftermarket heads that the stock heads don't have. But at the power level that you're talking about, I wouldn't spend it on heads. I would just spend it on the springs, the injectors, the turbo, just the camshaft, the things that you need. A few buddies that will be paying for their current builds for years to come. I'm excited to see how your low buck truck cam does. My ProCharge 4.8 two-wheel drive crew cab, and my buddy's lifted 5.3. Nice. Connecting rod failures. I plan to run 8 pounds most days, maybe 15 to 18 on break my truck days. I could see Tucson race on the way. There you go. I would really like to come out for the duct tape drags. That would be fun. Engine for my Z06 is paid off, about halfway done on the transmission. I owe nothing. Did you do a 4200 Big Bang? I haven't. I only ran a turbo at fairly low boost on a 4200. LQ9, 1200 to 1500 horsepower to the wheels, building a daily. How big a turbo should I go? Is it a daily, or is it 1500 horsepower, or is it both of those things? You need a turbo that will support that. The twin 3584s will definitely do that. A single G42 will not do 1500 to the tire. Richard, I'm curious, have you ever just ran the same motor, belt-driven supercharger versus a turbo? Yeah, I've done it 3 or 4 times. And so you can take a look at that. I have videos up. Take a look at the modular Ford where we ran turbos, a centrifugal blower, a Vortec. So shout out to the Vortec guys and the guys at Brian Tooley Racing. A Vortec, or a Paxton, the Eaton supercharger, and a twin screw Kenny belt. So you see the difference that the parasitic loss is associated with driving those blowers relative to the turbos at the same air fuel timing and boost levels. It's a lot. Thanks for the clarification. Would a G42 turbo still be your initial choice for 700 wheel horsepower on an LQ9? Yes, it would. Almost no need. Basically, Calvin did the Big Bang 42, and I haven't seen that. I haven't seen Calvin do a Big Bang necessarily on that, but he has run the boost up on those things. Rod's upgraded in Gen 4, I think in 2007. Is that what you're saying, or you're asking? Low buck truck cam is legit. I have it in my daily driver GXP. It's great. Hopefully the transmission lasts. Yeah, I can't guarantee that with the camshaft. It's hard to believe LT breaking rods when Amelia Hartford pushes 1500 from her LT2 and only bent the rods. Yeah, I don't think it's a strength issue, and they would have had to have changed something in the rod design and or the oiling to make a problem there. Just noticed some brass in my cam bearings. So many mixed opinions I've read so far. I don't know what you mean by brass. Are you talking about you can see the copper on them? Because that's normal. Truck runs good. I need to fix leaky passage side valve cover. So have you gone into boost yet, Todd? Leave 20-30% because we all want to turn it up until we see oil, rings, stiff gears, wrecked tires. It costs too much. It's a good rotating assembly for an LQ4. The Summit Pro LS stuff is good. Scat has good stuff. There's a lot of good stuff that's way better than factory stuff, and the factory stuff is also pretty good. Seen a couple of oil pump failures, but most are sudden connecting rod failures. That's weird. I wonder if they got like bad batches of metallurgy or something. Also need a TV cable adjusted. Oh, for the trans. Okay. Jet ignition uses a pre-ignition chamber to start the burn, then shoots the ignited fuel into a jet across the cylinder. This gives a lot more consistent top-down burn, helps with timing. So that's a CVCC that Honda did back in the 70s, basically. What they're doing is they're doing lean burn for fuel. This is normally used for fuel mileage and not for power. So they do lean burn
in the main chamber. And what the hard thing about lean burn, because I had a Civic VX that did lean burn too, and the way that the problem with that is getting a homogeneous mixture, because obviously if you don't have very much fuel in there, the fuel particles, the molecules are farther apart. And so what they do to get even mixture motion inside with when you're running lean burn is on the VX, they did it with mixture motion. So what they did was open, it's a 4-valve head. They opened the 2 intake valves at different points to induce swirl. On pre-chamber stuff like CVCC motors, they did what you're talking about. They ran a lean burn, but to get it to ignite, they ran a pre-chamber stratified charge. They ran a pre-chamber, and that had a good mixture in it. And then they shot that into the chamber so that they could get complete burn. And it worked really well. I mean, especially for those were carbureted motors back in the day, and it ran great, and they got really good fuel mileage doing that. Kind of like expecting more power from a bigger throttle body and engine that doesn't need the extra airflow. Yeah, you could put a 200 millimeter throttle body on a stock 4.8 and it's not going to do anything. The G3582s were $123 a piece at max speeding. Clearly, they are the finest turbos in the universe. Yeah, they are $123 though. I agree on ignition. I got 2 race engine customers pushing like 1,000, then 3 to 4 stages of nitrous. They're using Napa Belden Edge OEM wires and have been for 3 years. Yeah, all of my stuff. I mean, I had somebody send me Excel, or somebody sent me those wires that have the cool like ceramic boots on them that don't burn. And so those were cool. But I don't know that I've ever gotten new wires for the LS stuff that I've tested. No boost, just break-in miles. There you go. Baby steps. Good job. I've never seen someone plop 3800 supercharger into those North Star gasket blower caddies for peak, reliable, comfy cruising. You mean other than to replace the M112 or the 122 that came on those Cadillacs with an M90? Drove a turbo E46 for the first time. It was awesome. Rebuilt both engines over this winter, and now I'm waiting on torque converter for the 4T80. There you go. Didn't know Honda was doing that way back when. I'm gonna look into that. I was introduced to this via F1's current engine design. Yeah, look up a CVCC engine, and I don't think that they're the only ones to do it, but that's the one that I know about. Yeah, stratified charge. I'm sure if you go to and you have to pay for this, but if you go to the Society of Automotive Engineers, if you go to SAE papers that are written about this and did a search, you'll find that probably was done, hundreds of years ago. No, just replace the whole North Star engine in the Cadillac with a 3800, and said people take the Cadillac 4T80 and put it in the Regals and the GXPs. Okay. It comes using a stock engine with a bigger turbo. Does not take away the efficiency of the engine, but I need a bigger turbo to support the power. I'm not really sure what you're asking. I don't know why you'd put an 88-103 on a stock engine unless you're trying to utilize what an 88-103 has to offer. So that's what I'm saying. You have to decide what your power level is, and then I can size a turbo for you accordingly. You'd ring gap for 6 PSI GT45 towing only? Yes, I would definitely put ring gap any boosted application, especially if you're doing sustained towing where you're much more likely than doing acceleration runs. You're much more likely to put heat in the ring gap doing that. On rockers, Ugga-Duggas, no, I don't think that translates. Ugga-Duggas are good for like a balancer bolt. Is gapping piston rings necessary for a 5.3 planning to go to 700 horsepower? Yes. Gapping rings is necessary for, I would argue, for every boosted motor. Having said that, there are lots of people out there doing it without gapping them. And I ran boost on my 5.3 several times before we went in and put gap in it. Turns out it already had gap in it because somebody had replaced the rings. But I didn't know that and took a chance. And if it blew up, that's on me. How do you feel about spraying with nitrous? I have endless amounts of nitrous tests up there. I've run nitrous on every engine family that you can imagine. What would you say is perfect horsepower for a daily driver? I don't know what vehicle you have and don't know anything about what you're doing. I had a thought, not sure if tuners do this or if it would work, but while on the dyno, could you use a timing offset table while timing on a dial knob and adjust timing at different RPMs on the fly? How are you gonna? What dial are you gonna change that comes out of the? I don't understand how you're gonna do that with a computer and then some sort of external knob. How would you calculate how much gap? We run 6 thousandths to 6.5 thousandths per inch of bore. So 0.0065 times whatever the bore size is. If it's 4 inches, times 4. If it's 3.78, like on a 5.3, 3 times 3.78, and that will give you the gap that you need. Ideally, a 100 wheel horsepower truck and a 225 wheel horsepower sport bike. Both serve the needs differently. Spark plug gap. Yeah, Todd, I'd put it down at 20. I used to use CP Carrillo website. Okay, I love the CP Carrillo stuff. I've used their Bullet series stuff on a lot of things. What power nitrous level do you start to gap rings? I've run lots of nitrous without gapping rings, including an up to 300 shots. I think it's a good idea to gap rings if you're running nitrous. AAM 12 position dial switch. Yeah, I'm not familiar with what you're talking about. I don't know why if you have a standalone management system, why you wouldn't put the tune in there that you want to be in there. I have on carbureted applications run boost timing retards that retard the timing per pound of boost a certain number of degrees of timing, half a degree, 1 degree, 2 degrees, whatever per pound of boost. We've run those kinds of, like, it's basically just a rheostat knob on MSD ignitions or crane ignitions, those kinds of things. But I've not ever done that on a standalone management system. Bought property with pole barn, waiting to pick up twin post lift. I'm going to start fixing the GXP. Nice. Is it cool if I email you? I'm very confused right now. Yeah, you need to make it simple. You need to not go to different rabbit holes. How much power do you want, and what motor do you have? And then I'll tell you how you get that power. It's very simple. What oil do you recommend? 1,000 horsepower, mostly drag racing, drag a little and drive. I just put good. We run 530 on most of the LS stuff, and I just put a good synthetic oil in it. And then also, the weight that I would use might also be altered depending on how you did your bearing clearances. A 530, Todd, is what I would put in most LSs. If you can do rolling burnouts on a freeway, I'd say that's good for a daily driver. the turbo stuff is like that. Lack of ring gap means lack of ring lands on the pistons. Yeah. $580 turbo on an LY6 with a low buck truck camshaft. What would be the horsepower, and what is the best boost controller? What boost PSI? Thank you for sharing. I don't know what you're asking, really. Like, if you're choosing that turbo for that combination, you should be choosing the power output already if that's the turbo that you want. That's not a turbo where you go, how much power can I make on this turbo on this motor? You should pick a bigger turbo if you're trying to make more power. On a 6-liter with that turbo, I probably wouldn't go more than about 600 at the tire on that. And if you were trying to do that or wanting to go beyond that on a 6-liter, I would pick the bigger turbo. I'd pick a G42 for it. And boost controllers, I've used mostly a manual controller. Or if you had, depending on what management system you have, it's fairly easy to do a 3-port control with a Holley or any of these standalone deals. Stock rockers or trunnions for 500 horsepower, 6-liter. A stock rocker trunnion upgrades are a good idea if you have lots of miles on your rockers, but not for strength or anything. It's not necessary. I'm shooting for 1,300 horsepower with the ability to go to 15. Would .801 AR be too small for a 5.3? For twins on what size? Those aren't the 62 millimeter turbos, right? What size turbo is that? For Tom, I think what he means is set the dyno to hold an RPM and try to measure the power at different spark advance. But you can't read power like that, just spark, not threshold. I wouldn't do a stationary load and then start adjusting timing. What we could do is do sweeps starting at whatever RPM you want and then try timing. We do that as a matter of tuning anyways. So if we run it from, let's say we run it from on the engine dyno 2000, which is a stationary load, which is not what most people see on the street anyway. But if we run 2000 and go to 6500 and we run that RPM range, we add timing until it doesn't make any more power. And so at 2000 RPM, your motor doesn't want, nor will it respond favorably to very much timing because it has a low engine speed. And so the timing that you put in there has plenty of time to ignite the whole mixture and expand at the proper point without a whole bunch of ignition timing, without it happening early. As speed goes up, you have to have that thing ignite earlier to have it happen at the same point. The 3584 is not good for 800 wheel horsepower on a 6-liter. If more back pressure is on the exhaust side than boost on the intake side, would it be beneficial to advance cam to have exhaust valve closed by TDC and stop exhaust valve? You're worried about things that you shouldn't be worried about. What you should do is put a camshaft in there that makes a given amount of power, that produces the power curve that you want. Then you should add a turbo to that and multiply that NA power output. You're worried about valve events and you shouldn't be worried about that because none of that's going to come into play. Nitrous, if you go over 150 shot, gap the rings. Another question, with the LS6 or LS7 valve springs on a Gen 4, what's it safe to rev to? That's not the right thing. That's not the right question. The spring doesn't determine what the RPM potential is. It's one of the things, but it depends primarily on the camshaft. Because the motor will free rev to 8,000, if it makes peak power at 6,500, it's not a good idea to rev it to 8,000. Revving it to 8,000 is bad anyways because it's definitely gonna break something. But those springs are not designed to run lots of RPM. But they are designed to run with a specific cam at a specific RPM. To run lots of RPM, you have to have a cam that has a stable load profile and has the right spring, not just with spring rate, but with frequency for those to be able to do that. Heather, what is your question about the 1,000 horsepower 4.8 liter? I didn't see another question. I was kind of scrolling back. I didn't see what your question was. 540 full synthetic Rotella T6 for the win. Would lower inlet air temperatures or ethanol permit smaller ring gaps? I don't think that those are directly related. I don't think ring temperature is directly related to charge temperature. I think that there are other factors there. But maybe. I don't know how much influence the fuel or air temp or attending combustion temperature. Because if we lower the charge temperature but increase the cylinder pressure because we're making more power, does that put more heat in the ring or less heat in the ring? A lot of standalones have built-in boost control. Yeah, the Holly has the ability, like I said, to control a 3-port or whatever. So it is essentially a boost controller. It has control for that. I mean, you have to have the 3-port deal, but we'll email you tomorrow. I can get the Ilmor intake out this week if you're going to do a test. Is that Is that Ilmore intake? Is that for a rec port head? It's hard on the motor to dyno test it that way. That's why we do sweep tests. When it stops gaining power, you stop adding timing at the spot, or you really hurt stuff. Yeah, there's no reason to go, like if you load it, stationary load it at 2,500 RPM, and then start adding timing, that would be a dumb thing to do. That's why we sneak up on it. We know that it doesn't want 30 degrees of timing at 2,500 RPM. So we start at 15 or 20. We know what an LS wants. And so when we stationary load it, we see what it does. If we add a degree or 2 degrees and it doesn't do anything, we take that back away. And we might even try to go lower to make sure that we're going in the right direction. You only add until it stops making power. And we're able to do that on the engine dyno. We normally run good fuel. So if you were doing that kind of test, like a timing test where you're optimizing power production to the detonation threshold, you probably would run good gas on it. You might run E85 in it. We run the motor cold, so we're also able to do that. That's not something I would do at 200 degrees. The 6266s and 1,500 horsepower, I don't know if that goes together. I'd have to look at the maps for those. All right, Todd, I'll see you later. Singular twin turbo on a 4.8. You can make the power level that you were talking about with either one. The choice of singular twin is an aesthetic thing or a fitment thing. So the power thing is doable with any kind of turbos, any combination of singles or twins. Same size turbo, would you choose a T4 or T6? Is there a big difference in response? There would be a difference in response, and I would choose the T4 if I was scaled more toward response and the turbo was big enough to get to the power level that I wanted. Like, let's say I was going to do an S475 and I only wanted to make 900 horsepower. Then I'd pick a T4 version of that. If I wanted to max out the S475, then I would pick a T6 version of that. What's the benefit of twin versus a single? Like I said, it's just an aesthetic thing. It's not, I tested response rates, but you can get the same response rate with a twin that you can with a single if they're sized correctly. Does porting heads always reduce low speed power? No, not at wide open throttle. It doesn't. Motor is capable of 8,500. All my race engines come with dyno sheets and 2-degree increments over, say, 10 to 20 degrees, so racers can see how much power comes from track tuning. I don't understand that. Why would they give you a dyno sheet where they have where they would start timing at 10 degrees where the thing's making no power? I have a Summit Pro LS Stage 2 cam and I've yet to install the 26 to 2800 stall on the 6L80. Cam is fairly small. Yeah, a 2800 stall converter is definitely going to help. More fuel, less heat. How do you feel about Summit Pro LS torque converters? I was told Circle D makes them. Yeah, Summit's not a torque converter manufacturer, so somebody is sourcing them for them. I don't know who it is. If it's Circle D, Circle D makes good stuff. I've never tried any of their converters though. Will a GTX 3584 RS work on a 6-liter? Yes, it definitely will. It's the turbo that I would choose for a daily driver where you're not wanting like a ton of power, where you're wanting a ton of response. The advantage of twins over singles is you can't do mirror image with a single. Yeah. The Ilmore intake is rec port. Okay. Did you Steve Morris with drag pull tractor? Did I see Steve Morris? Is that what you're asking? So 500 to 550 is doable with the GTX. Yeah, we've made 800 with that turbo at the flywheel, so that amount is not going to be a problem at all. I have a 2010 Gen 4 5.3. Okay, that's good. We got one more minute. We got 62% saying yes, they would go big, go to the big side on the twin turbos. What's your favorite turbo setup on a 4.8? I don't have a favorite setup. It doesn't, my mind doesn't work like that. What I do is testing to show people what happens when you do things. So if you run a 4.8 with this cam in and this intake manifold, these cylinder heads, and it makes this much NA power, and we add this much boost, it's just going to make this much power. It doesn't matter if we do it with twin turbos or a single turbo, it's just going to do that. As long as the turbos are capable of supporting that power level, that's what it'll make. So it doesn't really matter. I want to run twins just because I haven't for a while. Probably make 500 on spring pressure. Yeah, that's, and if it's a cammed 4.8, then it's going to be pretty easy to make that kind of power. 78, 75 seems to work well on a 6-liter. Yeah, I like Viron stuff. That works. What's the biggest turbo you've put on an LS? Probably I'd have to look back and see if we ran that GT55 thing on a that Viron sent me. But two of the S475s we ran on the Big Bang motors. That's capable of 2000. We run dyno runs over 10 to 20 degree range in 2 degree increments using timing to kill power at spots for traction to take off issue. We find optimum timing, then drop back in increments. Oh, so you're trying to traction control with timing then? I mean, we run timing sweeps on stuff. I just didn't know that other people that were building race motors did that. I mean, I understand what you're talking about now. That's a good idea if you want to find out how much power you can take away. What are your thoughts on eBay piping kits? I can't weld, and exhaust shops are hard to come by. If you're talking about the discharge side, the cold side, like tubing is good. Like all the aluminum tubing stuff is good, and clamps and all of that is good. I don't know about the hot side stuff. It's wild that we're talking about 6 to 7 wheel horsepower being low. that's actually a lot of power. You should do twin Pro Mod turbos just to see how deep you bury the rods in the floor. It's like using Holley EFI with trans control to pull timing on launch or something. Those guys are still carb guys, so timing light's useful. Compound turbos on gas engines, is it worth a headache? There are instances where a compound turbo might be beneficial on gas engines, and race guys have done it before. I don't see the need for it for like your normal street LS kind of turbo thing. I don't know where you would need that. 1050 2-inch injector for under 600 wheel horsepower. I got them in trade for mechanic. No, as long as a 1050, our 1000cc injectors are what we ran on our 5.3. We ran it naturally aspirated. We ran it on E85. But we also ran it on gas. And so as long as you can tune that and take away enough fuel to get it to idle right and do all that stuff, that's not a problem. 1000s are not a problem at all. We've run 4.8s with 1500s. Can you talk about wastegate placement? Yeah, your wastegate placement should be in line with the exhaust flow. You should prioritize the wastegate with exhaust flow. So if you have your exhaust comes out of your head, your cylinder head, into your exhaust manifold, and then they all merge together and are going, this way, this direction. Your wastegate should be right here. The exhaust flow should hit your wastegate and then turn up, and then the turbo should be up here. Build a Temu from LS. Yeah, I'm not interested in that. I wouldn't use that stuff. I wouldn't use their lifters. There's lots of stuff that I wouldn't use. Intake manifolds, yeah, as long as it bolts on, it seals, that would be fine. I don't think I would use throttle bodies from there. I definitely wouldn't use lifters. I don't think that I would use, I wouldn't use springs. I definitely wouldn't, I don't think I would use camshafts. There are some things that I would and some things that I wouldn't. I wouldn't use head studs. I wouldn't use gaskets. I wouldn't use any of that. In your torque cam video, were you saying if you wanted to torque down low, it's better to go boost? Yeah, you can make a lot more torque at whatever RPM you want by adding boost. So for instance, if you added a positive displacement blower, as soon as you step on the throttle, even at 2000 RPM, you're going to have a lot more torque. Or a small turbo can also do that. What are your thoughts on running on 2 fuel pumps? I think everybody does it. I like an internal pump because it's cooled by the fuel, and that's why I like the dual pumps that go inside the tank. But saying that, my Mustang ran for 10 years with a feed pump inside the tank, and it fed an external Bosch 930 turbo or 928 Bosch pump for my Vortex supercharged motor, and it lasted forever. It was low. The pump was, that other pump was low. In fact, it had a bypass around it with a check valve on it. So the stock pump could be run while I'm driving around, and I only turned on the secondary pump when we were like doing boost. I should have had it on a Hobbs switch. It would have been much smarter, because there were times when it was run without that. Hard to believe killing 10 horsepower on 3 to 4 stage nitrous car can change the launch. 30 degrees at wheelies, 28 hooks. Yeah, and that's where the, you know, guys that are drag racing and especially doing no prep stuff, you got to find that balance. And that's hard. So wastegate and a crossover pipe, yeah, you could. That's where, if you look at all of my videos, I run 2 wastegates in the crossover pipes. HPT said their 6266 is capable of 850 horsepower. Okay, well then you're all set. Do you ever do any LS VVT cam testing? I do not. I haven't been able to control the VVT stuff because we haven't used any of the factory ECUs. Have you ever seen an LS 2002 computer coil driver die? And a factory one? I've seen computer coil drivers die in aftermarket ECUs. I haven't seen it in a factory one because, again, we don't use them on the engine dyno. Do single turbos create more back pressure than twins at the same power level? No, I don't think so. If you size the turbo so that you have 1,000 horsepower turbo and you have 2 500 horsepower turbos, and you've sized the hot sides accordingly, the back pressure should be comparable. Can you explain how mounting at the crossover pipe is equivalent to mounting near the turbo? It 100% is, because I've taken measurements everywhere in the exhaust system, all around the, like right at the exit of the exhaust manifolds, everywhere in the cross pipe, right before the turbo. And we've taken back pressure readings and it's all the same. Everywhere in that pipe, it's the same. What you're interested in is the exhaust flow going out of the wastegate. So you want to position it so that the flow goes into the wastegate and out of the wastegate when the wastegate is open. You don't want a wastegate to come out 90 degrees to the exhaust flow, and you don't want it to be close. It doesn't necessarily need to be close to the turbo to have control. Not at the level that we're talking about. I back probe from coil to pin 27. Yeah, I don't. That's beyond me. And on that note, it is time to go. But I will, as always, I'll see you guys all tomorrow.